So I got kind of tired of our cubes dominating the arrow. I actually wanted to be able to see the arrows, so I translated the cubes a little further apart so that we can see the arrow. The way we currently have our data set up right now is that we have a vertex array object that we store the cube data in. So this is cube vertex data. We have an index buffer for the cube index data, so cube index data. And then we also create another buffer for the arrow vertex data. Look how straight that line is. Oh, and this one too. Makes me feel good. Anyway, the arrow vertex data. And we have another buffer for the arrow index data, which is fine and dandy. But if you create a buffer for every single one of the geometries you load up, chances are you're going to have an insane amount of buffers. And so it's possible to actually combine this data into one buffer. Okay, we will put the cube vertex data here. And then we'll put the arrow vertex data here. So all the vertex data will go in one buffer. And then for the index data, we'll put the index data in one buffer as well. This will be the cube index data and the arrow index data. And this actually isn't that hard. I encourage you to pause the video and actually write the code to do it before I show you how to do it, but this is the end goal. We're going to combine our vertex data for both objects into one buffer and our index data for both objects into one buffer. So let's do that. Let's go to send data to OpenGL. Hopefully you're turned up to high definition. Instead of having a cube vertex buffer ID, I'll say this is the vertex buffer ID. It will be the vertex buffer for both the cube and the arrow. And we'll have the index buffer ID as well. We can get rid of this, get rid of this. We'll maintain our vertex array object so we don't have to do all the attrib stuff. And then right here I'll say this is the vertex buffer ID. We'll bind the vertex buffer ID to our array buffer binding point. And then when we do buffer data, we could send down all the data at once for both the cube and the arrow, but then that would cause us to have to allocate yet another array and then copy all that data into that array and then send the data down to the buffer so that OpenGL could store it. Instead, what we're going to do is say GL buffer data. We're not going to have shape anymore. We'll have cube and shape data arrow. It's shape generator, make me an arrow. And then I shall say I need a buffer large enough to store the cube's vertex data plus the arrow's vertex data. And we'll pass null here, 0, saying we're not going to send you any data now because we'll send it down in pieces so I don't have to make yet another intermediate data array on the heap. So GL buffer subdata, we've seen this call before. I want to send data down to the buffer bound to the GL array buffer binding point. The offset is where in that array or that buffer, at what byte do you want to start saving this data? Well, it'll be byte 0. I'm going to put the cube at the beginning of this buffer. We'll have one big long buffer. The cube vertex data will be here, and then the arrow vertex data will be here. So start the cube vertex data at byte 0. And then the next argument is the size. Well, cube dot vertex buffer size. That's how many bytes I need. Then the data. We've done this before. Cube dot vertices. That's the pointer to the data. Now let's put the arrow in. GL buffer subdata. We'll put the arrow after the cube. So send this data down to the buffer bound to the array buffer binding point. And the offset's different. It's not 0. We sent 0 in for the cube because that's where the cube starts. The offset's right here, and this byte is the first byte after all the cube data. Well, how do I know what that byte is? It's the size of the cube vertex data. So cube.vertex buffer size. The size of the data I'm about to send down is the size of the arrow data. In fact, the way I've drawn this, it looks like the cube and the arrow take up the same amount of space, but I believe the arrow takes up just a little bit more. Anyway, the size of the data will be the arrow dot vertex buffer size, and the data will be arrow dot vertices. Okay, so one buffer, and we just sent all the data down to this one buffer, both for the cube and for the arrow. We need to do the same thing for the index buffer. We'll have another buffer for the cube index data and the arrow index data. The logic is pretty much identical to what we just did. We'll say the index buffer ID. Copy that, bind to it. Buffer data, we'll say no data on the first call. We'll send the data down later, but we need enough memory for the cube index buffer size plus the arrow dot index buffer size. This is identical to the logic that we used right here for the vertices. GL buffer sub data, send down to the buffer down to the GL element array buffer, the buffer that's bound to that binding point. At 0, we want to send cube dot index buffer size. Here's the cube indices. So now we just sent down the cube index data starting at the 0th position right here. Now let's do the arrow. Okay, same thing as we did before. We need this offset for the arrow, which is the size of the cube index data. So we'll go right here and say GL buffer sub data, GL element array buffer, and we want to offset it at the end of the cube. The arrow will be offset at the end of the cube, so same thing as we did before. Cube index buffer size. How much data are we going to send down? It will be arrow dot index buffer size, and the data is arrow dot indices, like so. And I think we're good. Now we still need to track the number of indices in both the cube and the arrow, because when we say draw elements, we're required to send that data down. So I shall say cube dot num indices will be the cube num indices. Get rid of that. And arrow num indices will be arrow dot num indices. And we're done with this. We don't need another buffer for the arrow because we combined it with the cube. And we don't need any of that as well. However, our vertex arrays, our trib pointer calls, well, now instead of having our trib pointers point to two different buffers, we need to point to one buffer for the vertex data and one buffer for the index data. We only need to set up the offsets a little bit differently. And we're going to require these offsets. For example, we have the cube vertex data. We need this offset still. We could save it away so that we could use it in this function, but I'm feeling dirty. I think I'll just delete this setup vertex arrays function and merge it with the send data to OpenGL function. We shall generate our vertex arrays as we did before, bind the cube one, enable the attributes, all that's the same. But then we want to bind the vertex buffer ID. The attrib pointer for 0, well, since the cube vertex data is the first set of data in the vertex buffer, it's offset 0 for attribute 0, which is the positional data of our vertices, and then 3 floats in, we find our color data, which is attribute 1. So these two GL vertex attrib pointers are okay. And we also bind the index buffer ID. And then we go and bind the arrow vertex object ID. Do all the same stuff we did before, except this needs to be the vertex buffer ID, and this needs to be the index buffer ID. Our attrib pointers have to change up a little bit, though, because the attributes for the arrow are going to come in here. It's still 0 from the beginning of the arrow for the positional data, and it's still 3 floats for the color data, so that'll take us in a little further. But we need to get past this cube vertex data. So to get around the cube vertex data, we're going to simply add cube dot vertex buffer size here, plus 0. Well, plus 0, I can take the plus 0 out. Attribute 0 will come at cube vertex buffer size, but again, this is an old function. It requires a pointer, and so I'll say void star. In fact, I noticed I did char star before, which just implicitly converts to a void star, so I don't know why I just didn't say void star to begin with. But we shall cast cube vertex buffer size to a void star, even though it's not really a void star. It's an integer byte offset into our buffer. Then same thing down here. Let's change this to void, and we will say cube vertex buffer size plus, wow, that's kind of hard to read, plus the size of a float times 3 to get us into that color data. Now there's only one other hiccup, and that is where we call PaintGL. When we say draw elements, there's this argument at the end which indicates where do the indices inside the buffer begin. And for the cube, that's easy. It's 0. It's 0. But the arrow, it's not 0. The arrow index data starts here now. With the vertex attributes, we set up the vertex arrays and did the attrib pointer calls, and that solved the problem for the vertex data buffer. But the problem's not solved for the index data. We have to maintain this byte offset so we can pass that byte offset right here for the arrow. Now there is a way to set up a buffer and send the data down to a buffer that would store all this, but I think it's actually kind of more of a headache than just tracking that byte offset. But so we're going to have to do a little bit of hacking here. It'll kind of be frustrating, but GLUint arrow index data byte offset, and then the byte offset will just be the number of bytes that the cube index data takes up. So down here we'll say arrow index byte offset gets data dot, not data, cube dot index buffer size. And now that that's all done, I can say cube, please go clean up, delete your data off the heap, and arrow, please clean up, delete your data off the heap as well. So this is our hackish number here. Let's go down to draw elements. I'll pass that byte offset there, and it's complaining that uint is not compatible with a void star, so we'll do the same trick that we always do. Actually, I guess we don't need parentheses there. We'll just cast that into a void star, and I think we're good. Let's just go up here. The vertex buffer ID, the index buffer ID, cube vertex array object arrow. Okay, I think we're good. Control F5. Of course, it doesn't build. Because setup vertex arrays, I deleted that one. Setup vertex arrays, that was a linker error. Let's go to the header file and also delete setup vertex arrays there. Control F5. Hopefully this renders what I think it should. And we're good. Yeah, we still have our arrow and our cubes. All the data stored in one buffer, or I guess 2 buffers instead of 4. The index data in one buffer, the vertex data in another buffer. And while we're at it, something about this cube. Notice the red, green, and then on the bottom is blue. That's a nice, or not the cube, the arrow. That's a nice thing about this arrow is you can always tell what the top is. The top's red, sides are green, and the bottom is blue. And I think on this side of the arrow, yeah, I made it kind of a yellowish side, and on the right is a greenish side. But anyway, I digress.